Hi, welcome to the drop-in session. If you have any questions at all, just pop them in the chat, and I'm gonna write on the blackboard to help you with anything that you put inside there. Yeah, I actually have a student who's doing the Irish Leaving Cert. I don't know if you wanted help with a question in particular. I'm gonna add that to the description as well. I think the cert is when's that exam? I think it's in a couple of days. Or is it the 7th, I think? The cert leaving exam, isn't it, for the maths one? "2023 paper 1 long questions." It's quite soon, it's quite soon. Although GCSEs have already started, I think. I'm going to see if I can find that paper. 2023 paper 1. Go on, let's have a look at so you want long questions. Is that section B? Yeah, that's section B, isn't it? Any of those in particular, or section B exactly? Good. Questions 7 and 8. All right, let's have a go at this then. Go on. So we got working out a speed to begin with. Let's see if this works on the screen as well. Okay, yeah, that looks like it comes up all right. So when we get a question like this and we're working out a speed when we're passing a point A, so we know that, hang on a second, is this all of the question? Yeah, it is, isn't it? Fantastic. Okay, so we know t is the time after passing the point A. So at the point A, we know that the value of t is 0. And so what we're going to be doing is substituting this value into the formula for v. So if you like your function notation, you can write it like this, v of 0. So everywhere I spot that t afterwards, I'm just going to replace with a 0. Okay, and hopefully you can see that anything that's multiplied by a 0 is just going to disappear, going to vanish. And that's going to leave us with 109. All right, and if we move on to part B then. Okay, So hopefully you should know. I'm gonna have to assume that you do know this one. That acceleration can be worked out by differentiating the velocity. So when we go from velocity to acceleration, that process is going to be differentiation. Okay, and if we take our formula Vt and we differentiate that, we can write it as V dashed of t, which I've just said is equal to the acceleration, still going to be a function of t. And if we bring that power down and subtract 1 from it, we're going to get 2t squared minus 12t plus 13. So that's now our formula for acceleration. Okay, and it's asking for us to find the acceleration 5 minutes after she passes the point. So we know that t equals 0 is at the point. We're obviously looking for t equals 5. So in function notation, I can just write it like this. So that's 2 times 5 squared minus 12 times 5 plus 13. Okay, and if we work this one out, I think it's 3. Yeah, that looks about right. All right, so do you have any questions so far? Is that all okay? Yeah, of course, we can have a look at some related rates if you want to. Let's have a look. Is there a harder related rates question on this one? Sure, I'll see if I can find one. I don't know if you want to take a look at this question, see if that looks like, what did you say, related rates question. Perfect. All right, good. So whenever we get a question like this, the goal is to sort of combine a variety of derivatives, right, to find what we want. So we've got a volume. I think this might be quite an easy one, actually. This might be quite an easy one. So show that the volume of the tank is given by V equals 18x minus this. So we should draw a little diagram first, probably. Yeah, that's a good tip. Always draw a diagram for these questions. So we know that the height is x. This is x because the vertical face is a square. And we don't know this length yet. Let's call it a y. We are given one limiting condition. That limiting condition is that total surface area of the sheet metal. So we can create a formula already, right? We can create a formula for the surface area is x squared. We've got 2 of those. We've also got those 4 rectangular sides. That's going to be xy. Oh, it's a tank, isn't it? It's a tank, so there's no top. Yeah. So that's only going to be 3 extra sides, the front, the back, and the bottom. Okay, and we know that that is equal to 54. Fab. So the next step, okay, is going to be relating together the volume and the area. So we started off with this sort of bit of information about the surface area of the tank. We need to relate it to what the question is actually asking for, which is a volume. So let's create a little formula for the volume. It's very easy. It's just a cuboid, so that's x squared y. And hopefully you can see where this is going. From this first bit, I can make y the subject of the equation and do a substitution into the volume equation, right? And I'm going to skip over some of those steps unless you'd like me to carry on with them. I think those are relatively easy to understand. So I just rearrange this top equation, okay, and plug in whatever y is equal to the volume equation. That will work out part A. Okay, and given that x can vary, use differentiation to find the minimum or maximum value of v. Well, this means that v can vary with respect to x. And whenever we have sort of any variation with respect to a quantity, that means we do the derivative with respect to that quantity. So what I'm going to be trying to find is dv dx. Okay. So if we do the derivative, that's what we get. And it asks for us to find the maximum or minimum value of v. And hopefully you should know that on a curve, if we're at a maximum or a minimum point, then this change in the volume is going to be equal to 0. So if we were to plot something like the volume against the value of x, so we know that when we change x, v is going to change, right? And the shape of the graph could be anything random like this, but we know that at this point, that is what we would call a maximum. This point, a minimum. Okay, obviously the gradient, which would be dv dx in this case, would equal 0. So to find the minimum or the maximum, we're going to pop that equal to 0. So 18 minus 2x squared. It's going to leave us with 9 equals x squared. If I square root both sides, I find that x equals plus or minus 3. However, it's a tank. X can't be negative, right? So we're going to eliminate that, and we're just going to finish with x equals 3. Okay, and once we've found the x value, we also have an equation that takes that x value to find out volume. So the volume when x equals 3 it's going to be something like that. Okay, and what does that work out? 36. All right, and how do we justify that something's a maximum? Well, there's a couple of ways to do this. We can test the gradient either side, or we could do the second order derivative. Okay, and if the second order derivative, which would be dv dx squared, at a maximum point, we can see that the gradient is getting lower and lower, so this would be negative. And if it's greater than 0, we know we would be at a minimum. So we can do that second order derivative, which would be minus 4x. And we know that the x value is 3. And I like to write it like this. So if I'm evaluating a derivative at a place, I'll draw this long line afterwards and then write down the value that I want to evaluate it at. So x equals 3. So if we pop that in, okay, you can see that that's minus 12. And we said that if that value was less than 0, we'd be at a maximum. Okay, so we've shown that it's a maximum there in that question. All right, so hopefully you understood that one all right. Let me know in the chat. Did you want something more difficult after this, or? Yeah, so should we have a look at a slightly harder question then? Yeah, of course I can find a hard one. Okay, hopefully this one... Oh, you have a question? Yeah. We can, of course, have a look at that first if you want. Alright, let's try and find that. Yeah. Yeah. DEB Mock 2023, Paper 1. That's going to be hard to find. Okay, it's okay. Yeah, I need to empty it first, though. And do you have a link to that? I don't know if you can even post links in the chat. DB Mock 2023 paper. Let's try again. Yeah, I don't think I can find that question. Let's have a look. It's something that you done at school, or? Look up DB Mocks and it's the first link. Right. Okay. So, yeah, this... DB pre-papers. Aha, fantastic. Actually, this is a good site. Thanks for letting me know about this site. I'm just gonna save that one. Right, cool. Question 8. So is the radioactive, Is this the radioactive substance question? Nope. Oh dear. 2023 paper 1 question 8. Let's try that again. 2023 paper 1 question 8. Can you tell me what the question's about? Oh, it is. It's 2024 you wanted. That's all right. Okay, so this one's the grain silo question. Is that right? Nice one. All right. Okay, so let's have a look at this. Okay, so when we get long written questions like this, one of the things that I like to do is to pick out the key pieces of information, right? Before we even get started. To me, this sentence here is going to be the key information. That's what I'm going to be able to create an equation from. Okay, so I'm going to look for how to work out the volume. That's going to be the volume of a hemisphere plus the volume of a cylinder, right? So yeah, if we just work that one out, we know that the cylinder is pi r squared multiplied by the height plus half, and then we know it's 4 over 3 pi r cubed. Okay, we can simplify this, and now we can set it equal to the 625 pi over 3. And that's nice. With these questions, with the 3D shapes, you'll often find that pi's cancel on both sides. That's really nice and useful, because you know you're kind of on the right track. Okay, and we want the height of the cylinder in terms of r. So we can rearrange this one now. Okay, and we can divide through by r squared. I've done that quite fast. Just type if you have any questions. We can move the 3 to the bottom line. So then h would be 625. It's 2r cubed. Then we've got our 3r squared on the bottom. Okay, so that's part I done. Let's move on to the next bit. Okay, so we've got surface area of the silo. I don't want Siri. So the surface area of the silo, including the base, is given by this. So again, it's just a surface area question, right? We obviously want half of the sphere's surface area at the very top. So we know, that's 4 pi r squared multiplied by a half. So that's the surface area of a sphere multiplied by a half. That's what we want to keep. Okay, we also know that we've got the bottom. So I've already done this surface. I need to do this surface. That's just pi r squared. And of course, there's the sides now of this cylinder. So if you imagine it being stretched out into a rectangle, you know that that's 2 pi r multiplied by h. Okay, and if we take a look at this formula, there's no h. Okay, that's what we're going to aim to replace then. And that's why this is part 2, because we can take that h formula and plug it into there. So I'm just going to speed through this bit, right? So get a final answer down. Okay, that's just algebra. That shouldn't be too complicated. I think the next part should be, yeah, okay, so we're minimizing something now. So, again, this is a long question, right? What I'm going to want to do is take little pieces of information and try and write them down in equation form first. That's my first thought when I read a long question like this. So I know what the area is, and if I'm going to minimize the area of the sheet, just like before when we're talking about minimum, right? We know that we're going to need to find the gradient and set it equal to 0. So I'm going to at some point need to work out dA dr. Okay, and I want to retain the capacity. Okay, I want to retain the volume. So that means the volume is not something that can change. Okay. But we've already worked out, let's do this dA dr bit first. Okay, so that's going to be 10 over 3 pi r. That's an r on the bottom there. Okay, so be careful with this one. Is r changing? Let's have a look at the question again. No, r's not changing, right? Okay, so we can differentiate that one. What's that going to be? Minus. Okay, so we found dIdr, and when we want to, when we want to find the minimum value, right? We said that we want to set that equal to 0. Okay, so I can times through here by r squared. I can times through here by 3. Either of those is fine. I can also divide both sides by pi. Let's do a bit cancelling to begin with. Let's write some stuff down. So 10r okay, times both sides by r squared. So we've got this. Divide both sides by 10 and then cube root. So that's going to give us r equals 5. Okay, so that's the value of r that minimizes the sheet. It does say, what does it say? Do we need to check that it's a minimum? Well, since there's only one value, it's definitely going to be a minimum. I don't think we would need to check that. But if we did, we could do it like before, where we do the second order derivative, check whether that's greater than or less than 0. That would be fine. But it wants us to work out the area of the sheet metal required. So we go back to our equation for A. We pop this down. Then we want A evaluated at r equals 5. So that's what, 5 pi times 25 over 3. Something like that, which is 125 pi. Okay, and is there another part? Well, there's lots of parts. All right, let's keep going then. just fix my screen sharing. No, it's alright, it's no worries. How did you see the stream, by the way? Just out of interest. All right, okay. We can let's carry on with this question here. So there's 3 grain silos. Oh, fair enough. Fair enough. Yeah, I don't think there's many live videos. People doing this at the moment. Nice. Okay, so company wishes to purchase 3 grain silos. Restriction in space. The largest radius that can be accommodated is 2.5 meters. So we've got a limitation on the radius. Find the height of the silos required to retain the same capacity. So we're going to need to vary. We're going to need to change h and find a new h this time, right? We worked out the volume for one of these shapes earlier. Okay, so that was pi r squared h plus 2 over 3 pi r squared. So remember the shape of that silo from the first bit of the question, and we want the same capacity. And if we go back, the capacity was that 625 pi over 3. Okay, and we know that r is 2.5, right? So that's going to place some limitations on this equation. Of course, like before, we can cancel out those pi's on both sides. I'll leave us with something like that. You can see that's just an equation in terms of h now. Right, so we can just solve for that. We can just go through, divide through by that 2.5 squared, subtract away that 2.3, right? We'll end up with that. And it asks for the height of the silo, which is very, very mean, because the actual full height of the silo is that, right, where we have a radius and the actual height. So you have to pay close attention to these questions. So what we can do is we can say we're going to do r plus h, so 2.5 plus what we just found, right, which is 34.2. Okay, correct to 1 decimal place. Okay. All right, so we've got another shape here. What's this? A pyramid? All right, you can see that. All right, got you. So grain from the silo is fed into this pyramid, It's got a square top. Okay, so square-based pyramid. Find the capacity of the vat. So that's the full capacity, right? So when there's no room at the top left. So we know that any pyramid is a third of the volume of the full 3D object. So if this is a square-based pyramid, then the full 3D object, oops, drawn that terribly. Full 3D object is going to be that, right? Which is a cuboid. Okay, so a cuboid is very easy to work out the volume of. It's just base times height, and we're just going to want to take a third of that. Right, nice and easy. So now if we've got similar triangles or otherwise, we want to show that when the depth of the grain is y meters, square free surface of the grain has sides of length 2y. What does it mean by square? Let's have a think. Okay, so we've got that the depth of the grain, or the height of that grain there, is y. And we also we could use another variable here. It's probably the easiest. Oh, it's me. What terrible hay fever today. That's what's happening. Oof. Okay, so we could say that this square side, well, maybe it's a certain fraction, right? A certain fraction of the free surface. So we can say if the depth equals y, okay, the square side, we just put that as 2 times a fraction. Okay. What does it mean by square side? Hang on a second, let's have a think. It doesn't mean this thing. It means this thing, doesn't it? It means the top. Right. So you know that using similar shapes, that the scale factor between the small and the large is y to 5. So if the large is 2, then you know this side here is going to be 2 times something, 2 times a fraction. Okay, maybe it's easier, I think. If we write it as a ratio like this, okay, and that must equal x in ratio with 2, like that. I think that's a bit easier to understand with the similar shapes. So that written in fraction form is like that. Yeah, I think it's a bit simpler. Just use those scale factors in there. Okay, and then finally onto a rate section. Okay, so we know we've got a change in volume in this question, right? Because we've got grain coming in, right? The grain is rising. So we know that the volume is going to change. And actually, whenever you see this word rate, whenever you see that, you should be thinking something dt. So you're always going to do the derivative with respect to time whenever you see the word rate. And that's a really useful thing to know, because you can read the question, not be too sure what to do. You just know it's something dt. Yeah, I think I'm going to take a break as well. Okay, so we've got something dt. Well, what's changing? I want to find, okay, the level of the grain, how that is changing. Okay, so that's which letter? That's y. Okay, so I want to find dy dt. What we also have is the volume changing. So at some point I'm going to have dv dt. Okay. I'm also going to have v as something that is related to y. Because if we have a look at the volume of the full thing, right, it's that. But that 5 would need to be changed for a y, and that 2 would need to be changed for an x to get a general formula, right? So v in general would be 1 over 3 times that side x, right? So x squared times y. Then I also know that x is now 2y over 5. So can you see I've got a general formula of v in terms of y now. The reason why I needed that is because in order to relate together these two derivatives, we're going to have to manipulate, okay, another derivative in order to get dy dt. So it's kind of like cancelling fractions. We can now put in dt. Oops. We don't want to get rid of the dt, right? That's on both sides. So we want to get rid of the dv. So I'm going to need dy on top, dv on the bottom. I can see that that's going to cancel. That's cool. Yeah. If you need to go, not a problem. No worries at all. If anyone else has a question or a topic they want to go through, I'm happy to take any other questions. You weren't even watching it. There's no way you were watching it. Maybe I should stream myself playing League at the same time. I'm not doing that. It was pretty crazy. I've had 4 people watch in like 50 minutes. That was pretty mental. Do you actually have nothing better to do with your time? Like, actually, like, why don't you just mod the chat? Oh wait, there's no one in the chat. But you could pretend to mod the chat. No. Okay. Well, fucking fair. I can't argue with that. You wanna come around for come around for a barbecue a bit later? Actually, just come around and barbecue me food. Yeah, can you do that? Pete, there's children. Beanie, there's no people in this chat. There's one person in this chat, and it's you. To be fair, I stream myself playing Minecraft. Now there's 2 people in the chat, Beanie. Now you can't say that anymore. And they've gone. They probably read your messages. Fuck's sake. I'm trying to figure out how I can. Oh, I need to plug everything into the big laptop. I don't know how to share the screen